In this lesson, we are going to have a look at factorizing algebraic expressions. Now let's start with the word factorizing. What does it mean? In simple terms, it basically refers to putting the expressions back into its brackets form, right? And the first step of factorizing any algebraic expression is for looking for a common factor, right? So if there is a common factor present in the algebraic expression, the first step is to take that out, and that leads us to the first step of factorization. Now, in this particular topic, we are going to have a look at factorizing expressions with 2, 3, and 4 terms. Now, with this particular lesson focused on 2 and 4 terms, right? So the first step, right, for expressions with 4 steps, for 2 terms, the first preference is to look for the use of the difference of perfect square formula, right? For those who can't remember that, that's basically your formula where we have 2 brackets in the form a plus b times a minus b, which is equal to a squared minus b squared, right? Obviously, given we are trying to factorize the expression, a question in this particular topic is going to be given in that format, and the question will expect us to factorize it into its brackets form of a plus b times a minus b. Right, so let's jump straight into this, the first set of examples. So factorizing expressions with 2 terms, right? So the first question is minus 3x take away 12, right? I can see that there are 2 terms here, minus 3x and minus 12, and they do have a common factor. Right? The common factor there is being minus 3. So if I take out minus 3 out, right? So when I say taking out minus 3, what we're basically doing is we're dividing each term of that expression by minus 3. So if I divide my first term, which is minus 3x, and if I divide that by minus 3, all I'm going to be left with is x. And my second term, minus 12, if I divide minus 12 by minus 3, I'm going to be left with is a positive 4. Right, and that completes the factorization of that particular expression. Right, let's move to the second example. So again, we have 2 terms, 20a squared plus 30a. Right, so we'll look for common factors again, and we can notice that this expression has a common factor of 10 for the numbers and a for the variables in the question. So if I take out my common factor 10a out of the equation, out of the expression, I mean, so we divide each term by 10a. So if I divide my first term by 10a, I'm going to be left with 20 divided by 10 is 2. A squared divided by a is simply a. Right, I'm dividing my second term by 10a is going to simply leave us with a positive 3. And that completes the factorization of that algebraic expression. Now let's go into this third example. Right, the first question I'm going to ask you is, how many terms are there in this expression? Right, and the key to answering that question is terms are always separated by addition or subtraction, right? And that tells me that in this particular case we have 2 terms again, right? So 2 times x plus 1 being one term, and a times x plus 1 being the second term with a subtraction in the middle. Alright, and again we look for common factors. So what's a common factor in these 2 terms? I can see that they both have a bracket in common, right? So what we're going to do there is we're going to take out the bracket out, which is x plus 1 is the common factor in that expression. If I take that out, all I'm left with in the first term is the 2, and the thing I'm left with in the second term is just simply minus a. So what we've basically done is we've taken out x plus 1, which is the common factor, out, and we've factorized this expression into 2 brackets. Now, obviously, what we looked for here is we have looked for the common factor in each of these examples, and that has helped us factorize each of these expressions. Now moving further, right, so here we have an expression x squared minus 16. Right, let's first talk about a common factor. Do we have a common factor in there? I don't think we do have anyone, right, other than 1. Right, and taking out 1 doesn't make any difference. Right, this is where our thought process need to shift to the fact of using the difference of perfect square rules, right? Now I can see there are 2 terms. One is x squared, the other one is 16, with a subtraction in the middle, right? And I know 16 is a perfect square, right? So if I rewrite this expression in the format of x squared minus 4 squared, I can clearly see that it compares very well with our difference of perfect square formula, which is a squared minus b squared, factorizes as a plus b times a minus b, right? And that's what we're going to use in this example to factorize this expression. So my a being x and my b being 4, this expression is going to factorize in the format of x plus 4 times by x minus 4, right? And that completes that question there. Right, second example, 9a squared minus 4b squared. Right, again, we don't have any common factors, right? But I can see that 9 being a perfect square and 4 being a perfect square. I can rewrite this example, or this expression, as 3 times a to the power of 2, which is going to be 9a squared, take away 2 times b, or 2b to the power of 2, which is going to result in 4b squared. Right, now we have the expression written in the format of a squared minus b squared. So we now apply the difference of perfect square rule, the two brackets being 3a plus 2b times 3a minus 2b. Alright, and that completes that example. Now moving on to the third example in this particular section. So we have 12y squared minus 1452. Right, now again, this is not a very straightforward example because in this expression, yes, there is a common factor, and the common factor there is 12. Alright, so if I take out the 12 out, I'm left with y squared minus 1452 divided by 12 leads us with 121. Right, the reason I say that it is not a very straightforward example is because to know that 12 goes into 1452 121 times is not natural, right? So in more likely than not, we might have to use a calculator for this example, right? So now I have taken out my common factor, right? That's always the first step. If there is a common factor, take that out, right? That's going to always lead into the or it's going to make it easy for you to factorize the algebraic expression. Right, now inside the bracket though, I do have two expressions, y squared minus 121, right? And I know 121 is 11 squared, right? It's a perfect square. So if I rewrite that expression inside the bracket as y squared minus 11 squared, right, what I have inside the bracket is a case of the difference of perfect squares, right? So which will then further factorize into two brackets as y plus 11 times y minus 11, right, and thereby completing that question. Right, one last example, right, in this section. So x plus 3 to the power of 2, take away 4, right? Question for you, how many terms are there, right? And the answer to that is there are two terms separated by a subtraction in the middle, right? And we know that the second term, 4, is a perfect square. So if I rewrite this expression as x plus 3 to the power of 2, as it's given in the question, take away 2 squared. Now that is again going to represent itself in the format of a squared minus b squared, right? Where the value for a being x plus 3 and the value for b being a positive 2, right? And that's going to factorize as a plus b times a minus b in this particular format. So x plus 3, which is my a, plus b, which is 2, times x plus 3 minus 2, right? We can further simplify this. Obviously we have like terms inside each of the brackets. 3 plus 2 giving us 5, simplifying the first bracket as x plus 5, and 3 minus 2 giving us a positive 1, which leaves us with the second bracket as x plus 1, right? And that's how it factorizes itself into. So if we quickly have a look at what methods we used here, right? In example C, we looked at removing the common factor, but more commonly across all the four examples, we basically had to use the difference of perfect squares to factorize the expressions. Alright, moving further along, right? Obviously in this example, we are having expressions which has 4 terms, right? And the best way, or the most preferred way to factorize expressions with 4 terms is with a process called grouping. So what we ideally do in this particular process is we take 2 terms at a time, take out any common factors, and then hope that it factorizes further, right? So if I jump into this first example, right? If I jump into this first example, I'm going to have a look at the first 2 terms of this question, right? And I can see that that has a common factor. The first 2 terms have a common factor of x. So if I take out the x out, right, I'm going to be left with x squared divided by x is x, and minus ax divided by x is simply minus a. So I'm going to be left with x minus a inside the bracket. Now, if I take into account my second pair, which is minus 4x plus 4a, I do notice that they also have a common factor, which is 4, right? But if you look closely, right, if I take out a minus 4 instead of a 4, right, so if I take out a minus 4 outside, have a look at what happens there, right? If I take out a minus 4, the first term, right, minus 4x divided by minus 4 is going to leave us with simply x, and 4a divided by minus 4 is going to simply leave us with the minus a in there. Right, now what we've done by grouping in this particular section, we've grouped two terms, we've tried to factorize those groups, right? Factorizing those groups has left us with two terms, right? The first term and then the second term, separated with a subtraction in the middle, right? And what we can see very clearly is these two terms also have a common factor, right? Which is nothing but the bracket x minus a. So if I take that out, right, I'm going to be left with x for the first term and minus 4 for the second term, right? And thereby factorizing these expressions with the help of the process called grouping. Right, let's have a look at the second example, right? Again, we're going to try and group these terms. So I'm going to start with my first pair, right? You don't necessarily have to group the first pairs all the time. You can even go ahead and group x squared minus 5x. You know, you can use different permutations and combinations in terms of grouping. All right, it doesn't always have to be the first two terms and the last two terms. And also, you know, just grouping it in that format is not always going to work. So sometimes you might have to rejig the question, right, to see if you can get up a second step where you have two terms with a common factor. Right, so let's factorize this first two terms, right? The common factor being x. So if I take out the x, I'm going to be left with x minus 2b, right? And now if I look at my second pair, which is minus 5x plus 10b, right? And if I take out a minus 5 there, not a positive 5, I'm taking out a minus 5, so I can have a similar bracket. So that's going to leave us with x minus 2b, right? And again, we have reached a step where we have two terms with the common factor being the bracket x minus 2b. So if we take that out, right, we're going to be left with x take away 5, and that completes the factorization of that example. Right, I'm not going to go through the third example because it's very similar, right? You group the two terms and then end up factorizing it with the help of the grouping process. Now here's another example, right? This is a case of 4 terms, right? I have mentioned the word challenging, all right? That's definitely for a reason, right? Let's talk about this. Right, if I go ahead and group these terms, right? So if I go ahead and group the first two terms, right, I can notice that there is a common factor, right? So if I group the first two terms, I'm going to be taking out there's no common factor in the first two terms, obviously, right, which is a challenge, right? On the other hand, similarly, if I take the last two terms, and again, I don't have a common factor there, all right? So we're presented with a challenge here, all right? But what I do notice is I have two terms that is of particular interest to me, right? X squared minus y squared. If I group them together, right? If I group them together, that leads me to thinking about difference of perfect squares, right? And if I group the other two terms, which is 5y and 5x together, I can clearly see they have a common factor. All right, so let's go ahead and group it in this particular format, and that's what I was telling you earlier, right? We might have to rejig the question to group them appropriately, right? So if I think about these first two terms, right, I know very clearly that they factorize in the format of x plus y times x minus y, right? So difference of perfect squares, right? And if I take into account my last two terms, which is my 5y and 5x, and if I factorize that by taking out the 5, right, I'm going to be left with y plus x, or x plus y, whichever way you want to write it, right? Now we've achieved a step where we have two terms, right, separated by a subtraction in the middle. My bad. So we have reached two terms separated by an addition in the middle, and now I can see that the two terms have a common factor, and the common factor that I can see here is the brackets of x plus y. So if I take that out, right, what I am left with in the first term is simply x minus y, right, and what we're left with in the second term is a positive 5, right? And that completes the factorization of this question, right? Obviously this is a little bit off task, we are trying to use different strategies to factorize this question, and that's why I have mentioned the word challenging in the question. Right, now thank you for listening. Right, now there is going to be another lesson in my channel for you to look at factorizing 3 terms, and I'm going to go through a variety of strategies there, so I'd really appreciate for you to go and have a look at that as well at some point. Right, thank you for listening, guys, and have a wonderful day.